Sugar and salt crystals. What are crystals? Crystals are simply a 3D structure where all of the atoms of an element are perfectly arranged on an atomic scale. These can be made out of everyday materials like salt or sugar, and each crystal will correspond with the element it's made of. For example, in rock salt, the atoms will arrange themselves in straight columns and rows, which leads to the crystal of rock salt to be square and smooth. What is sugar composed of? If we looked at sugars at a molecular level, we would see that each grain of sugar is made of molecules called sucrose, which is a carbohydrate. The basic parts of a carbohydrate are a monosaccharide or simple sugar. These can be seen in our experiment as glucose and fructose. These simple sugars can be connected infinitely but are sometimes linked as sucrose, a disaccharide made of glucose and fructose. Intermolecular forces in the reaction. In sucrose, which is represented by CH2OH plus H2O, all of the molecules are attracted to each other by intermolecular forces. Intermolecular forces in molecules is strong enough to pull the molecules and move them, but is not strong enough to break the atom's bonds inside the molecules. Molecules begin binding to one another to form the sugar molecule, but at the same time sucrose molecules already present in the crystal are dissolving back into the solution. The rate of dissolving is slightly higher than the rate of joining, so that's why sugar is always in a dissolved state while present in water. In the picture, you can see sucrose molecules leaving the solution and joining the solution to slowly form a sugar crystal, but also staying saturated. Dynamic equilibrium. Like stated in the previous slide, the rate of molecules leaving the crystal are higher than the rate of molecules entering the crystal, so they would need to be a way to stabilize this process to extract the crystal as a solid. With the introduction of more granulated sugar into the solution, the rate of dissolving is decreased but not enough to stabilize the crystal. The only way to form the sucrose molecules into a crystal is to cool down the saturation and cause it to become supersaturated. In supersaturation, more molecules join the sugar crystal in an attempt to bring up the temperature. These new joining molecules puts the crystal into a state of dynamic equilibrium, or perfect state to be extracted as a solid. In the graph, if red represented crystals molecules joining the solution, while blue represented crystal molecules leaving the solution in a state of hot water, the green line would become the sugar crystal that would be stabilized enough to be extracted. Epsom salt crystals. Epsom salt crystals are formed in similar ways that granulated sugar is made into sugar crystals. Epsom salt is basically the chemical compound magnesium sulfate or MgSO4. Heating or cooling the water will change how much MgSO4 can be present in the solution, i.e., it will dissolve more when the water is hotter and connect more when the water is cooled down. As the solution becomes cold, there is less room in the colder, denser solution, so the Epsom salt molecules begin to bump into one another and join together in a random crystal structure. This is why salt crystals are more jagged and irregular than sugar crystals. This can be seen in the pictures below.
To make sugar crystals or rock candy, you need around 3 cups of sugar, hot water, sticks or something for the sugar crystals to stick to, and food coloring if you really want to. You can add flavoring in there if you're going to eat it, because it is edible.
12 seconds later.
Okay, first thing you want to do to make sugar crystals is you want to have the water boiling, and once you have the water boiling, you want to add a cup of sugar in and stir that up until the sugar is dissolved into the water. And you want to keep doing that for all 3 cups of sugar until all the sugar has dissolved into the water, or can't dissolve into the water no more. Once you created your sugar solution, allow the solution to cool a bit before pouring it into a jar, and allow it to cool for around 15 minutes or more before continuing on with creating the sugar crystals.
Eventually,
before continuing to making your sugar crystals, you want to get your sticks or whatever you're using and dip that in water and cover it in sugar, allowing for the crystals to form easier on the stick and the sugar on the stick.
a few inches later.
Once you have created your sugar solution and have let it cool down for about 15 minutes or more, this is where you would get some cups and add food coloring to it. And you want to add the food coloring before you add the solution. And if you're going to eat it, you can add flavoring to it right now too. And once you have done that, you want to pour in the sugar solution and put in your sticks or whatever covered in sugar into it. Once you have poured in your sugar solution and put in your sugar covered sticks, all you have to do is wait a few days or weeks, depending on how long you wait is how much sugar crystals will form around your sticks.
Tomorrow. Day 2. Day 3.
Once you are satisfied with the sugar crystals forming around your sugar sticks, you want to take a knife or something to break the top of the sugar solution. Once you break the top of the sugar solution, you want to pour out the surplus of the solution into a different cup or bowl. Once you have done that, you want to let the crystals around the stick to just sit there and dry off from all the other surplus of sugar solution.
One eternity later.
After about 3 days, this is how our sugar crystals or rock candy form. The longer you allow the solution to sit there, the more crystals or rock candy form around your sugar sticks.
Tomorrow.
To make Epsom salt crystals, you're going to need Epsom salt, water, and food coloring, but the food coloring is optional.
A few inches later.
So to create Epsom salt crystals, you want to have 1/2 cup of Epsom salt and 1/2 cup of hot water. The goal here is to heat up the water to allow it to dissolve as much as the Epsom salt as possible. Then later, as the water cools down, it would no longer be able to hold or keep a lot of the Epsom salt in the solution. This will force it out and cause a rapid crystal growth. Once you have finished stirring the solution, you want to let it sit there for about 15 more minutes and let it cool down. Once it has cooled down, you want to pour it into a beaker or a container where it can hold the solution. Once you have done that, you want to put that beaker or container into the refrigerator where the solution can cool down and form the crystals.
3:28 a.m.
So here is a small time lapse of the Epsom salt crystals forming. So what's happening here is that cooling the solution rapidly encourages faster crystal growth since there is less room for the dissolved salts in the cooler, denser solution. As the solution cools, the magnesium sulfate runs into each other and join together to create a crystal-like structure.
6.5 hours later.
This is the end result of the Epsom salt crystals.